Hello, Whittier High School. This is Mr. Quattro. We're going to do notes today on 11.3. This is a pretty quick one. So first, a couple definitions. A histogram is a type of bar graph that shows the frequency of ranges of values. And by ranges of values, I mean, if you see in our examples, we're talking about the number of tickets that are being sold. We're not talking about how many people sold one ticket or two or three, but a range from 1 to 8, from 9 to 16 tickets, from 17 to 24, and so on. So it's for ranges of values. And then I use the word frequency up here to define a frequency table. A frequency table just shows how many times certain values happen or occur in a data set. So there's a couple different ways that distributions can be shaped, and we're going to see those today. There's what's called, we'll start in the middle, symmetric, where the left and the right side are the same. So down here it says the data on the right are approximately a mirror image. So it's symmetric. It's the same on both sides. And it's important, we're going to see this in a second, but approximately a mirror image. Nothing in the real world is perfectly symmetric. And then there are two, if it's not symmetric, it's one way or the other. So skewed left is when the values kind of tail off to the left. And you can see we call this the tail. So the tail extends to the left, and most of the values, most of the data is on the left. I'm sorry, I take that back. Most of the data are here on the right. I take it back. And then for skewed right, the tail of the graph extends to the right, and most of the data are over here on the left. All right, so let's do an example and you'll see how this works. It's actually pretty simple. So we've got a frequency table here that shows the number of raffle tickets sold by students in your grade, and we're going to draw a histogram. So we have all the information we need, that 5 people sold between 1 and 8 tickets, 9 people sold between 9 and 16, and so on. And so we're just going to make a bar graph over here that shows that. So for our 1 to 8 bar, it needs to be as high as 5, which is right there. So we go up to 5, go over, you can shade it in lightly if you want. And then for 9 to 16, we're going to go all the way up to 9, which is almost the 10. And then from 17 to 24, we go all the way up to 16. $25. 20. 8 and 7. So there's our histogram. Pretty simple. And then they want us to describe the shape. So now it's not perfectly symmetric like up here, but it's pretty close. The tallest is in the middle, and the left and the right are approximately the same size as each other. It's not dramatically skewed one way or the other. So we would call this, when they say describe the shape, we would say this is symmetric. That's a histogram. Now, let's look at one more thing here. So, depending on the kind of distribution, it helps us make a choice here. So we've studied mean and median before. In a symmetric distribution, the mean and the median are about the same. So they're about the same. So what we're going to use to describe the center, if we're talking about all of this, like on the previous example, how many raffle tickets did people sell? To describe the middle, we would use the mean. If something is symmetric, we use the mean to talk about the center or the middle. If the data is skewed one way or the other, though, the mean will be in the direction where it's skewed. So you can see in our two examples here, the mean kind of gets pushed over towards the tail, and the mean gets pushed over towards the tail on this side. So the mean, it gets moved a little bit, and it doesn't give the best picture of what's happening. And so instead, if a distribution is skewed, we would use the median to talk about the middle. So for a symmetric distribution, the mean is the best way to talk about the center. For a skewed distribution, the median is the best way. All right, one more example of one of these, and I went ahead and did some of this for you, so I didn't have to count them all here. In this one, we've got a police officer measuring the speeds of cars driving by, and he just writes down all the speeds. So what I did is I just counted up with tally marks how many of each speeds happened over here, so we didn't have to do that on the video. So there was only one speed that was between 31 and 35. There were 3 that were between 36 and 40. So these are our frequencies right here. And so we can make a histogram over here. So for the 31 to 35, it's only 1. So this one's counting by 2, so let's just go 1 is right here. For 36 to 40, we're going to go up to 3, and you get the idea. 5, that was a bad one. 6. This one's the tallest one. This goes all the way to 11. And then 4. All right. So first, let's look at what kind of distribution this is. You can see on this one, it's not symmetric. It's definitely skewed left because we've got most of our values on the right and the tail goes off to the left. So this is, we would say, skewed left. And we said up above, if something is skewed, to talk about the center or the middle, we would use the median to describe the center. Then they ask one other question here, a little interesting question for the police officer. If the speed limit was 45, how should he interpret this? Well, we can notice that if this is 45 right here, this one is 41 to 45, right at the end of that. And if you imagine a line right here, look at all these people that are speeding. So the thing that we might notice is that the majority of people are speeding. All right, and then one more thing really quick, just one more example, looking at a couple different distributions here. So this is, here's the example. It says emoticons are graphic symbols that represent facial expressions. They convey a person's mood in a text message, and I think you already know that. The double histogram below, 2 histograms, double histogram, shows the distributions of emoticon messages sent by groups of females and males. So we can look at up here, this tells us females, and down here is the males, and you can see the number of emoticon messages they sent in a week. So they just want us to compare. So you might notice up here that the females, definitely pretty symmetric. So we would say females, symmetric. And the males are definitely pushed to one side. So you can see the values on the left skewed to the right. The tail goes to the right. So if we think back to the notes we just wrote down before, if something is symmetric, we would use the mean to talk about the center. And if something is skewed, we would use the median. And then one other thing we could say is we don't know exactly what the mean is, but you can see the middle here. The middle for the females is right around in this range here. And if you go down here, it's somewhere between in the 30s of emoticon messages sent. Whereas the boys, if you found the median is down here much lower. We don't know exactly, you can't tell exactly by just looking at the graph, but you can see definitely the middle is down here in the 10 to 19 range probably, because most of the values are actually very small. So if we had to make some kind of a statement about what's happening here, we would say that the females sent more messages. That is it. Now go try the practice. Have a good day.